Hello everyone. So let's now solve question number 5. Consider the set of three vectors in R3 with the usual addition and scalar multiplication. Find the value of C so that the above set S will be linearly dependent. So for the set to be linearly dependent, we want the linear combination of the set vectors in the set S, right? Gamma times 1 comma C plus 1 equating to 0 comma 0 comma 0. We want these coefficient, at least one of them, to be non-zero, and that would happen when the system of the linear equation would have infinitely many solutions. If we try to formulate the system of linear equation, it would be alpha plus beta plus gamma is 0, alpha plus beta plus gamma equal to 0, 2 beta plus c plus 1 times gamma is equal to 0. The augmented matrix would be if we try the REF form for this matrix. Yes, sir. Now, here, the system will have infinitely many solutions only when we get one row as the zero row. So let's consider the third row. This row will be zero row when the c minus 1 should be equal to 0. So c minus 1 should be equal to 0. So we will get c equal to 1. So that is our answer. So let's now see a different approach for the same question. So this time, as we have three vectors in R3, we will be putting these vectors column wise in a matrix, and now these vectors will be linearly dependent when the determinant of this matrix would be equal to 0. So if we try finding the determinant of this matrix, I will be finding the determinant along the first row expansion. So this is the determinant that we will get, and when only this determinant is equal to 0, we will get these vectors as linearly dependent. If the determinant is non-zero, then the vectors are not linearly dependent, they are linearly independent. So on equating this determinant to be equal to 0, we will get, so again we got the same answer. Let's solve question 6. For how many values of A is the set linearly independent? So we have one fact regarding the linear independence and dependence, that if we have m vectors in Rn such that m is strictly greater than n, then those vectors are always linearly dependent. So here, as we have four vectors in R3, so This set will always be linearly dependent. So there is no value of A such that this set can ever become linearly independent. So our answer would be 0. Thank you.